Hello guys, welcome to DTW tutorials. Welcome. Okay, so today this video is on a complete 40 questions solve and explain on Jamb 2017 physics. Okay, a lot of students after the one on maths, that's your last year Jamb maths. You can check that out on my channel. Okay, it's there for there's a 2017 maths. It's also going to help you to prepare for your forthcoming exam. Okay, so and sorry this is coming late. A lot of students have been saying, please physics, please ma, please do physics for us and all. So I've just tried to make sure I wrap this up tonight for you to make sure you pass this exam, especially a particular student called Duro Nelson, and I think his name is Isaac. You guys must pass these exams. Okay, so this video is not for sale. Please, not for sale. Please, not for sale. It's free. It's a CSR from DTW tutorials. All right, it's free for students. DTW tutorials, we support students with their maths and also some physics, okay, to ensure in Jamb, to make sure they pass the exam. So we support you in Jamb, your WAEC, your GC, NECO, and your post-UME. Please try to subscribe and follow us for your post-UME for your different schools. Okay, we have already questions solved on OAU, Unilag, and UI. Okay, so during the course of the year, I'm going to add other schools, Unizik, Uniport, Uniben. Okay, other schools, I'm going to upload their solved maths post-UME questions. That's their past questions. Okay, so please, this video is not for sale. And just subscribe also to DTW tutorials to support us to do more. And also, if you don't have maybe MB, you're an organization, you need this, I would also be willing to burn a copy for you on a CD to share to your students. Okay, this is just to help people with their education. All right, okay, that's students with their education. So thank you for staying tuned to DTW tutorials. You are destined to win, and don't forget, Jesus Christ is coming soon. Give your life to Christ. Okay, so let's get on to the video. Thank you. Number one question of UTME 2017 physics question says, a waterfall is 420 meters high. Calculate the difference in temperature of the water between the top and bottom of a waterfall, assuming no heat is lost. And we are given our specific heat capacity of water. Remember, the quantity of heat from our formula is what? mc theta. Okay, and here we are given a waterfall, all right, with a particular height. So we're going to Q will also be the what? Potential energy. Remember, Q is measured in joules, which is energy, that's the heat energy. Okay, so where PE, which is potential energy of this waterfall, will be what? mgh. Okay, so it will be mgh equal to mc theta. Okay, so here M would cancel out. The question we're looking for the difference in temperature, that is what? Theta. Where C is your what? Specific heat capacity, and we've been given this. Okay, so here theta is equal to what? G, which is the gravity, because it's falling, the waterfall falling from a height, which we've been given as 10 minus 10. Okay, GH divided by your specific heat capacity. So what do we have here? G is what? 10. Then our height is what? 420 meters. Okay, G is what? Meter per second square, and we'll divide by what? Our specific heat capacity, which is what? 4.20 times 10 raised to power 3. So here we can move this dot like 2 times. Okay, when we move this 2 times, we have 1, 2, so we have 420, right? So we'll have 420. Okay, let me write this down so you understand what I'm doing. Times 420 over 420. Since we've moved 2 times, decimal place 2 times, we're going to reduce this power by 2. So we have times 10 raised to power 1, which is the same thing as 10. So this will cancel out as 1, and 10 will also cancel out here as 1. And what is our answer is 1. So the difference of in temperature is what? 1 degrees Celsius. And our right option here is option A. Question 2 of our UTME 2017 physics past question. It says, a body when slightly displaced is said to be in a neutral equilibrium only if it tends to option A says comes to rest in a new position with the center of gravity and height remaining unchanged. Okay, so this is the correct option. B says return to its original position. C says remain in the displaced position. D says move further away from its original position. Okay, just for a brief revision here, you know you have three different types of equilibrium. You have your stable. Okay, for your stable equilibrium, it will tend to move to its what? When you slightly displace it, it tends to move back to its original position. Okay, so this one goes back to its original position. All right. While you're unstable equilibrium, it would move further away from the original position. And this is like in, you know, the examples given of stable and unstable. If you put a cone, okay, a cone with on its base, it is on a stable what equilibrium. No matter when you move it, it will go back to what its original what position. While if unstable is when it's on its tip, okay. While for your neutral, it's when its line is on its what surface, that's on its body. Okay, so unstable, it will move further away from original position. Okay, further away from position. Let me just shorten this here. Okay, and your neutral, it would come to rest in a new position, okay, with the center of gravity and height remaining unchanged. So our right option here is option A. Question 3 of our UTME 2017 physics past question. It says, that's your CBT exam, it says a string of length 5 meters is extended by 0.03 meter when a load of 0.8 kg is suspended at the end. How far will it extend if a force of 6 Newton is applied? Okay, so how do we do this? Now, it's just simply remember Hooke's law. Hooke's law says that your force is what? Directly proportional to what? The extension. That's provided the elastic limit is not exceeded, the extension E in an elastic material is proportional to the load or applied force F. Okay, so you introduce a constant K, which is known as your elastic constant or stiffness. Okay, and when you introduce this constant, we have what? F is equal to what? KE. All right, F is equal to KE. So here we are told from our question, we are asked how far will it extend if a force of 16 Newton is applied. First of all, we need to find our K. In getting K, what do? F. To get our F, first of all, F is the same thing. Since we've been told that it is suspended by a load of 0.8 kg, that's mass, okay, and you know, with a gravitational pull acting on that load of 10 meter per second square. So where F is also the same as what? Mg, equal to what? Ke. Okay, E has been, we've been given our E as our extension, which is 0.04. Okay, so we do here, definitely K will be equal to what? Mg over E. And what would this give us? What is M? M is 0.8 times 10 over 0.04. Okay, so in calculating this, what do we have? Let's say we move the decimal point. You know, we have to be fast in our Jamb. Okay, move it in 2 places. So it means we have to move here also 2 places. Okay, so we have 80 here, we have 4 here over 10. So 4 here 1 and 4 in 80 will give us what? 20. So here we have what? 200. So K is what? 200. So the question says how far will it extend if a force of 16 Newton is applied? So we have now a new force which is 16 Newton. So we're looking for E. Okay, how far will it extend? So K is already giving us what? 200. So our E will be equal to what? F over K. And what is F? That is what? 16 over 200. All right. So let's cancel out. What are we going to get? We're going to get here 4 here, 4, and 4 in 20 will give us what? 50. 2 here, that will give us 2, and 2 in 50 will be what? 25. So 2 divided by 25 will give us what? 0.08. Okay, so this is our answer, 0.08 meters. And our right option here is option D. Question 4 of our UTME 2017 physics past question says, which of the following has negligible mass? Okay, so A says protons, B says gamma, C says beta particles, D says alpha particles. Okay, the one of negligible mass is your correct option here is option B, which is your gamma rays. Okay, proton, don't be confused about this proton. Proton has a mass, and proton's mass is about, I think, 1.0072 mu. Okay, and beta has a mass of 9.1 times 10 raised to the power minus 31 kg, and alpha also has a mass of 6.65 times 10 raised to the power minus 27 kg. Okay, so our right option here is option B, gamma rays, which have a negligible mass. Question 5 of our UTME 2017 physics past question, it says, how can energy loss be minimized through eddy current? Okay, so this is quite simple. You know, anything eddy current, if you want to minimize energy loss, all you need to do is what? Laminate the core. And what is the meaning of lamination of a core? It just means insulate. So anywhere you see insulate, that's your answer. Okay, so question option A says by using high resistance wire, no. B says by using insulated soft iron wires, which is what our correct option here. The remaining options are wrong. Okay, so insulated soft iron wire, or if on the option you see laminated. So those are the two words you look out for. Okay, so our right option is option B. Question 6 of a UTME 2017 physics past question, that's our CBT exam. It says calculate the upthrust of an object of volume this 50 centimeter cube, which is immersed in a liquid of density this. Okay, we're given G also. All right, so we're to calculate the upthrust. And remember, upthrust is the same as what? Either the loss in weight or the weight itself. Okay. And remember, the formula to get weight is what? W is equal to what? mg. So this is our upthrust. But first of all, we have to look for our mass, which is m. All right. And to get our mass, since we are given density here, remember the formula of density. Density is what? Mass over volume. All right. So let's look for our mass. So to get our mass, m is equal to density. You know the symbol for density is this. P mu, okay, times your V, okay. All right, so what's our density? That's what? 10 raised to the power 3. That's 1000. Okay, 10 raised to the power 3 is same as 1000. Or okay, let me just leave it this way. Then times our volume is what? 50 centimeter cube, and we have to convert this to meter. Okay. We have to convert this to meter cube. Okay, in converting to meter cube, what do? We divide by 1 million. All right, that's just 1000 twice. All right, so when we divide this, it means this 1000 twice these 3 zeros can cancel out these 3 zeros here, and this 1 0 will cancel out this 1 0 here. So we are left with what? 5 over 100, and what's 5 in 100 is what? 20. So our mass is 1 over 20. So here, let's put in our value of our mass here into our weight to get our upthrust. So W is equal to what? Mg, which is what? 1 over 20 times, what is G? We're giving G as 10 meters per second, and we cancel out. So what do we have? We have 1 over 2, and 1 over 2 is what? 0.5 Newton. Okay, and our right option here is option C. Question 7 of our UTME 2017 physics question. There's a CBT exam. It says, which of the following would appear when a white screen is illuminated by red and green lights? Okay, so when you mix red and green lights, you should remember your lights, your color, spectrum colors. Our answer will give us what? Yellow. So the right option here is yellow. Question 8 of our UTME 2017 physics, it says, refraction, interference, diffraction. Which of the above properties are common to all waves? Definitely everything is common to all waves. Refraction, interference, and diffraction. And our right option here is what? Option B, which says I1 and I3. All right, so B is the right option. Question 9 of our UTME 2017 physics past questions that are last year question CBT exam. It says calculate the electric field intensity between two plates of potential difference 6.5 volts when separated by a distance of 35 centimeter. Okay, remember electric field intensity is equal to what? F over Q. That is what force per unit charge which it exerts at that point. Okay, and it's measured as what? Newton per coulombs. Okay, and it can also be measured as what? Volts per meter, which is what? Volts over the distance between the two plates, so which is volts per meter. So here we can relate this question to volts per meter. So we are going to use E is equal to VD, or V over D. So we have, what is our V? Our volts, our potential difference is what? 6.5 V over, and our distance is what? We have to convert our distance to what? Meter, to meter, because this is in what? Centimeter. In converting to meters, we have 35 divided by 100. So we're going to move this how many places? That's 1, 2. So we're dividing 6.5 over 0.35. And when we divide this, you know, you have an online screen calculator during your exam. When you divide this quickly, you're going to get what? 18.57 Newton. Actually, this is supposed to be voltmeter, but since it's still the same thing, just look out for your figure here. Our right option here is option A, which is 18.57 Newton per coulombs. All right. Okay, so our right option is option A. Question 10 of our UTME 2017 physics questions. Our CBT exam says the distance between the image and the object in a plane mirror is 40 centimeter. Okay, let's draw this. So we have a plane mirror here. Okay, this line is not straight, but this is a plane mirror, and you have the object here. Okay, and the image will be formed here. This is image I. Okay, and this is your object. Now it says the distance between the image and the object is what? 40 centimeter. All right, if the distance of the object is reduced by 9.2, that's the object reduced by 9.2, let's say it's somewhere here, what is the distance of the object from the mirror? That's the distance from, what is the new distance? And remember, in a plane mirror, the distance from here to here is I to, let's say this is the mirror, IM is equal to, and this is the object, is equal to what? MO. So, and we have been told that the total distance from here to here is 40. So it means here is 20 and here is also 20. So the distance of the object from the mirror will be what? 20 minus what? 9.2. And what's 20 minus 9.2? That would give us, I think, what would this give us? About 11. Let's do this together. 9.2. So carry a, there's a 0 here, a 10, so 8. Then we are left with what? 9 here, so this is a 0. And this will be a what? 1. Okay, so that will give us what? 10.8 meter. All right, or centimeter. But the fact here is that this question, I've tried to solve it in different ways. It doesn't have an answer. So I would advise not to pick an option here. Just leave it blank. Okay, it doesn't have a answer, so don't pick an option here. Any question you see, you've solved in different ways. You know, during the exam, when you solve once and you don't get the answer, you might feel there's no answer. No, you could just leave it. When you're through with other ones that are easy, then you come back to it and try several times. If you still don't get it, you leave it blank. All right, you understand? That's if you are very, very sure that you've tried all the probable ways to get that particular question right. If you tried and to no avail, you don't get the answer, the answers are not in the options here, so you can just leave that question blank. All right, don't pick any options. Okay, question 11 of our UTME 2017 physics question says find the potential energy of an object of mass 10 kg placed on a building floor 10 meters above the ground level. Okay, so what is our potential energy? PE is equal to what? mgh. Okay, and what's our mass? Our mass here is 10 kg, and we've been told that G, given our G as what, 10, and our height is what, 10 meter. Okay, so what is the answer here? This is simply just 1000 joules, and our right option here is option D. Question 12 of our UTME 2017 physics question says the volume of a fixed mass of gas is 10 centimeter cube when its pressure is what, 400 cm/Hg. Determine the volume of the gas when its pressure is what, 2000 cm/Hg. So when you see this, when you see volume and pressure relating, you remember that this is what, Boyle's law. Okay, so this is what Boyle's law. I know what's Boyle's law. Boyle's law is what your volume is what, inversely proportional to pressure, where you have your formula P1 V1 is equal to P2 V2. And also to just remind you also, you know, Charles' law relates what, volume to temperature. Okay, where Charles' law is V is proportional to T, therefore the formula is what, V1 over T1 equal to V2 over T2. Okay, so back to our question here. It says what, determine the volume of the gas when its pressure is this. That's why we're looking for what, V2. So V2 is equal to what, P1 V1 over P2. And what's P1? P1 is 400. All right, so we're still in centimeters, so there's no need to convert to meter. So 400 times our V1 is what, 10 centimeter, right? 10 centimeter cube. Okay, and our P2 is what, 200 centimeter Hg. So we cancel out this 2 here 1, 2 here 2, and 2 times 10 is what, 20. So we have 20 centimeter cube, and our right option here is option D. Number 13 question of our 2017 UTME physics past question. It says the product PV, where P is pressure and V is volume, has the same unit as. Okay, so we have what, PV. So we have to look what is another formula for P. P is pressure. Remember that pressure is what, F, that's force over area. And also V, what is the formula for V? V is equal to what, area times height. Okay, so when we multiply this, what do we have? That's P times V. P times V will be equal to what, F over A times A H. Okay, A will cancel area, and we're left with what, F times H, and H is in meters, so it's the same as saying F times distance. And what is force times distance? Force times distance is equal to what, work. All right, and our right option here, and work, you know, work is measured in what, joules, and our right option here is option D. Question 14 of our UTME 2017 physics past question that our CBT exam says, what is the cost of running 7 40-watt lamp and 5 80-watt lamps for 12 hours if the electrical energy cost is what, 7 naira per kilowatt hour? This should be hour. Okay, so 7, we have 7 lamps, that's 7 times 40, and what's 7 times 40? That's 280 watts. And we have 5 lamps with 80 watts, that's 5 times 80, and we have what, 400 watts. So our total wattage here is 086, so 680 watts. So our energy used is what, power times what, our time. How many hours did we spend? We spent 12 hours on this powering this bulbs, okay, which has a total power of 680 watts. Okay, so we have 680 times, what is T? 12. Okay, and what is 680 times 12? It will give us what, 8160 watts per hour. We have to convert watts per hour to kilowatt hour. In converting this, we divide by what, 1000, and we have 8.16 kilowatt hour. The question says what will be the cost, okay, if, and we've been given that if the electrical energy costs 7 naira per kilowatt hour. So all we need to do is multiply this by 7. So we say times 7 to get the cost we're going to pay maybe that month. Okay, so 7 times this, we're going to have, punching your online screen calculator, that's your on-screen calculator, we're going to have 57.12. Okay, so this is what the amount, the cost of running the total number of these lamps. All right, and our right option here is option D. Question 15 of the UTME 2017 physics past question and CBT exam. It says a thermal expansion of solid is an advantage in A. Balance wheel of a watch. No. B. Construction of steel rail lines. C. Construction of large steel bridges. D. Fitting of tires on wheels. Okay, the most accurate answer to this question is what? Construction of what? Large steel bridges. That is option C. Question 16 of our UTME 2017 physics past question. It says calculate the specific latent heat of vaporization of steam if 1.13 times 10 raised to power 6 joules of heat energy is required to convert 15 kg of it to water. Okay, remember heat energy Q is equal to what? mL, where L is what? Your specific latent heat of vaporization. Okay, and that's what we're told to calculate. Okay, we're told to find the specific latent heat of vaporization, and M is your what? Mass. M is equal to mass. Okay, and L is your what? Specific latent heat of vaporization. So L is equal to what? Q, which is our heat energy over what? M. And what is Q? Q is what? 1.13 times 10 raised to power 6, and to convert our mass is what? 15 kg. All right, so this, all we need to do here is, let's move this. If we move this decimal point 2 places, that's 2 places. So we have 113 times, reduce the 2 from 6, that's we have what? 10 raised to power what? 4 divided by 15. So you can easily divide this by 15. When you punch in your on-screen calculator, 113 divided by 15 will give us what? 7.53 times, then drop your 10 raised to power 4 joules per kg. All right, so our right option here is option C. Question 17 of our UTME 2017 physics question. Your CBT exam says a stationary wave pattern is formed by a wave of frequency 40 Hz and velocity 60 centimeter per second. What is the distance between the adjacent nodes? Okay, remember your velocity when it comes to wave is what? Your lambda times your frequency. Okay, where your lambda is also, which is your wavelength, is also equal to what? Your distance. Okay, so we have what? V is equal to what? df. All right, so here we're looking for what? The distance, which is what? D. Okay, and D, which is the same thing as also your wavelength, is equal to what? V over f. And what is our velocity here? Our velocity is this 60, and over our frequency is what? 40. Sorry, 40. So this cancel this, and we have 2 here, 2 here, 3. So we have 3 over 2. And when we divide this, we're going to have what? 1.5 what? Centimeter. Okay, so our right option here is option B. Question 18 of our UTME 2017 physics questions. It says calculate the height of the image. This is height of the image formed by a pinhole camera of length 12 cm used to photograph an object 60 cm away from the hole and 70 cm high. For a pinhole camera, always remember this formula. You have your magnification M is what? Image height over object height, which is same as what? Your either your length, image distance, which is the same as what? Your length of camera. Divided by your what? Object distance. Make sure you remember this formula. Okay, so we're going to equate this to this. So from our question here, what is the image height? We're looking for, from the question, yes, the question, we're looking for the height of the image, which is what? Image height. Okay, that is your what? Your V. Okay, so, and we are told it's an image height formed by a pinhole camera of length 12 cm. We know the length of the camera was what? 12 cm. Used to photograph an object 60 cm away. Object distance is what? 60 cm. and from the hole, and 70 centimeter high. The object is what? 70 centimeter high. Okay, object height 70. So from here, V is equal to what? This will cross multiply here. We have 12 times 70 over 60. So this will cancel out here. This 0 will cancel out. And 6 here 1, 6 here 2. So we have 2 times 7. And what's 2 times 7? That is what? 14 centimeters. So our image height is what? 14 centimeter. And our correct option is option D. Question 19 of our UTME 2017 physics question, your CBT exam says, from the diagram above, calculate the energy stored in the capacitor. Okay, so this is 8. Let me make this clear. 8 microfarad. Okay, so we are told to calculate the energy stored in a capacitor. Remember, energy stored in a capacitor is what? W is equal to half QV, where Q is also equal to what? Your capacitance times what? Your voltage. All right, so here, since we're not in our questions, we're not giving the capacitance, so we're just going to substitute your Q as CV into this equation. So we have 1 over 2. When you put Q as CV, we're going to have CV times V, which is the same as 1 over 2 CV squared. Okay, so here, what do we have here? We have 1 over 2. What is C? C we have been given as 8 microfarad. Okay, so that is times 8. Microfarad is 10 times 10 raised to power minus what? 6. Then times V square, which is what? 10. Our voltage is 10. So 10 square. And what is 10 square? 10 square is 100. So we can just leave it as 10 raised to power what? 2. Okay, so here, can we cancel out? Yes, we can cancel out. Okay, so 2 here, 1. 2 here, how many times? 4 times. Okay, so, and we have 10. Here we have 10 minus 6 plus 2. And what's minus 6 plus 2? That's what? 10 raised to power minus 4. So we're left with 4 here. So we have what? 4 times 10 raised to power minus 4. Okay, joules. Alright, so our answer is 4 times 10 raised to power minus 4 joules. And our right option here is option B. Question 20 of our UTME 2017 physics past question, that's your Jamb CBT exam. It says, which of the following is a scalar quantity? Remember what a scalar quantity is? It's a quantity that has magnitude with no direction. That's what scalar. Scalar has what? Magnitude, no direction. Alright? And your vector quantity has what? Magnitude with direction. Okay, so here, and what are the examples of scalar quantity? You can see from here, tension has a direction, weight also a direction, and our right option here is what? Your mass. Okay, so this is the correct answer, mass. Or examples of vector, other vector quantities are what? Your force, your velocity, and also acceleration. Okay, these are examples of what? Vector quantities. And other examples of scalar quantities are your what? Your energy, temperature, mass, and speed. All right, which mass is our right option here, which is option D. Question 21 of our UTME 2017 physics question. As your Jamb CBT exam, it says calculate the time taken for a mango fruit that fall from a tree of 20 meters to the ground. Okay, so from here we're going to be applying, you know, our equations of motion, and the right one to apply here is what? Your speed is equal to what? Initial velocity times t plus your what? Half at square. Okay, so since we're dealing with we're dealing with distance, which is s, the 3, okay, and we're also dealing with g, and we're looking for our time, which is t. Definitely our initial velocity is 0, so 0 times t, this will give us what? 0. So we're left with what? S is equal to what? 1 over 2 at square. So here we have s as what? 20 equal to what? 1 over 2 a, which is our acceleration due to gravity, since it's falling from a height, is what? 10 times 10, and we're looking for t squared. So cross multiply here, we have 40. Okay, 40 equal to what? 10t squared divided by 10, divide by 10, cancel, cancel. Okay, this will cancel, and we have t squared is equal to what? 4. And definitely t will be what? The square root of 4. And what's the square root of 4 is 2. So our answer is what? 2 seconds. All right, which is option D. Okay, let me just briefly remind you of the equations of motion. You have S also equal to what? V plus U over A times what? T, which is the same as this. No, that's different. Okay, and we have also V is equal to U plus AT, and you have V square is equal to what? U square plus 2AS. So in whatever questions, you know how to relate it when you are giving velocity and when you are giving acceleration and your speed, so you know how to pick from your equations of what? Motion. All right, so the right option here in this question is option D. Question 22 of our UTME 2017 physics question, your Jamb CBT. It says, which of the following instruments is most appropriate in the measurement of the thickness of a piece of paper? Okay, the most appropriate one with greater accuracy, vernier caliper, yes, can measure the thickness of a paper, but your micrometer screw gauge is the most appropriate to use because of its greater accuracy than your vernier caliper. So our answer is option C. Question 23 of our UTME 2017 physics question, your Jamb CBT exam, says, what is the energy of radiation that has the frequency of 8.2 times 10 raised to the power 16 Hz, where we are given Planck constant as this? Okay, whenever you see Planck constant and energy of radiation, I hope you remember, and that's the Boy's, okay, where he said that energy is only radiated when the electron jumps from one orbit to another, and the energy is radiated in the form of a photon of light with energy E, okay, and frequency F, which is what directly proportional to F. Introducing our constant H, which is Planck constant, we have what? E is equal to what? HF. So whenever you see energy of radiation, your formula is what? E is equal to HF. So we are told to look for E. So we have our H as what? 6.63 times 10 raised to the power minus 34 times, what is our F? Our F is what? 8, that's frequency, 8.2 times what? 10 raised to the power minus 16 Hz. Okay, so there's no minus here. This is a plus. Okay, that's plus, no minus, 16 plus 16. Okay, so here we're going to have here 6.62 times 8.2 times 10 raised to the power minus 34 plus 16. What would that give us? Minus 34 plus 16 would definitely give us, when we multiply these together, we're going to have 54.366. Then minus 34 plus 16 is what? Times 10 raised to the power minus what? 18. Minus 34 plus 16 is minus 18. And from here, if we move the decimal place one step forward, this will reduce by 1. We're going to add a plus 1. Okay, so we have 5.4366 times what? 10 raised to the power minus 17. Okay, which is same as what? 5.44 when you approximate this. And what is our right option here? We're looking for this raised to the power minus 17. Okay, this is our answer. So what's our right option here? Our right option is option A. Question 24 of our UTME 2017 physics question CBT, Jamb CBT. It says, under what conditions are cathode rays produced in a discharge tube? Okay, so the answer is just definitely at a low pressure and a high voltage. All right, so this is our right answer. It is not at a high pressure. Always remember, low pressure, high voltage. Okay, so our right option here is option D. Question 25 of our UTME 2017 physics question, the Jamb CBT, says, why do soldiers march disorderly while crossing a bridge? Okay, why soldiers march disorderly while crossing a bridge is because of resonance, to prevent resonance. You know, resonance is when, remember in the Bible, where the children of Israel walked around the wall of Jericho in an orderly format and the wall of Jericho crumbled. That's the first that's the first biblical, in fact the first history of the application of resonance. So in modern times, soldiers don't walk in a particular order while crossing a bridge, because due to that vibration of their march, they will set the bridge on vibration too. So, and when every bridge is on vibration, definitely it's going to collapse. So why soldiers march disorderly while crossing a bridge is to prevent what? Resonance. So our right option is what? Option A. Option B says to set the bridge into resonance, no. To make the bridge collapse, no. To spread their weight evenly on the bridge, no. So it's to prevent resonance on the bridge. That is option A. Question 26 of our UTM in 2017 physics questions, your Jamb CBT exam. It says in a pure inductive and capacitive circuit, where all the energy stored when the current is at, where is all the energy stored when the current is at the peak? Okay, now in a purely inductive and capacitive circuit, for an inductive circuit, the current always lags behind voltage, okay, by 90 degrees. Why for your capacitive, that's your capacitive, okay, current, this is inductive, let me write this here, and capacitive, okay, that's for a pure capacitive circuit. Your current is always leading, okay, it leads the voltage by 90 degrees. So with this particular statement here, it means that the energy in a pure inductive and capacitive circuit, if they are together, all the energy will be stored in the capacitor. That's when current is at its peak. So all the current will go to the capacitor. Since in an inductive, a pure inductive circuit, the current lags behind the voltage. So it means the current won't go to the inductor, but quickly travel towards the capacitor, because the current leads, okay, in a capacitive circuit. So the capacitive circuit, the current will quickly flow to the capacitor. So the question here is, the answer here is option B. So all the energy stored when it's at its peak would go towards the capacitor, okay? So the right option is option B. Question 27 of our UTM 2017 physics question, that's your Jamb CBT. It says calculate the voltage across a 5 microfarad capacitor connected to an AC source of frequency 50 over pi Hz when a current of 0.5 meter amp flows through the circuit. Okay, so that's V, our voltage, is equal to what? I times what? Capacitive what? Reactance. Okay, and where our capacitive reactance is what? 1 over WC. And remember that W is equal to what? 2 pi F. Okay, that's your frequency. Okay, where C is the capacitance. Okay, the capacitance of the capacitor. All right, so let's put in all these values into this equation. We have I, since XC is 1 over WC and WC is 2 pi F, we have I over W, which is 2 pi F times C. Okay, so what's our current here is what? 0.25 over 2 pi. What is our F? F is what? Times 50 over pi. And C is what? 5 microfarad. That's 5 times what? 10 raised to the power minus 6. Okay, so this pi will cancel out this pi. And here we have 2 times 50 is 100. And 100 times 5 is 500. So we have here 0.25 over 500 times 10 raised to the power minus 6. To cancel out this minus 6, let us reduce this 2 zeros. Okay, let's reduce this, shift this decimal place to 6 points to cancel out this. So we have 1, 2, 3, 4, 5, 6. Okay, so we have 0.25 over 0.0005. Okay, so we have this, and if you punch in your calculator on your on-screen calculator, this divided by this, we're going to get what? We're going to get our answer as what? 500. So we have 500 volts, and our right option here is option C. Okay, if you want to calculate this by hand, all you need to do is what? Shift this decimal place 1, 2, take this 1, 2, 3, 4. Okay, we're going to shift this 4 place, so it means we have to shift the upper part to 4 place. So we have 1, 2, 3, 4. So you have 2,500 divided by what? 5. And when you cancel out, you're going to get what? 500. Okay, this is calculated by just your hands. All right, so your answer here is what? 500 volts, and our right option is option C. Question 28 of our UTME 2017 physics question, your Jamb CBT says, if silicon is doped with phosphorus, what type of semiconductor material will be formed? Remember doping of semiconductors. If you want to form this, the answer to this question, whenever you dope silicon with phosphorus, you form an N type of what? Semiconductor. Okay, whenever you dope silicon with, let's say, aluminium or gallium or indium, you're going to get what? Your P type of semiconductor. For your N type, apart from phosphorus, you can dope it with arsenic. Okay, and you also get your what? N type of what? Semiconductor. So our right answer here is what? Option C. That is silicon doped with phosphorus will give us what? An N type of semiconductor. Question 29 of our UTME 2017 physics question Jamb CBT exam says a block and tackle pulley arrangement of 6 pulleys in which an effort of 50 N supports a load of 20 N. Calculate the efficiency of the machine. Remember now, this is a block and tackle pulley system arrangement. So our efficiency is equal to what? Our mechanical advantage over our velocity what? Ratio times 100%. Okay, remember a mechanical advantage is what? Your load over, let's write this as your load over what? Effort. And your velocity ratio for a block and tackle system is just the number of pulleys, which is what? 6. All right, that's divided by 6 times 100. And what is our load here? Our load here from our question is what? 200. And our effort, an effort of 50 divided by what? 50. So when we cancel out here 1, and here we have 4. 5 in 20 is 4. So we're left with what? 4 over 6. Sorry, 4 over 6 times what? 100. And okay, let me write this clearly out. 4 over 6 times 100. So here we can cancel out 2 here, 2, and 2 here is how many? We'll go how many times? 3 times. So we are left with what? We are left with 200 divided by 3. Okay, and what is 200 divided by 3? 200 divided by 3, 2 in 3 in 20. This will give us like 6 times 666. So we have what? It will go like 0.66. That's 66.7. Okay, so when we divide this, punch in your on-screen calculator, you're going to get 66.7%. all right, so this is our correct option. That is option C. Question 30 of our UTME 2017 physics question, your Jamb CBT says, which of the following is an advantage of the thermoelectric thermometer? Okay, the first one says it is not suitable for measurement of rapid changes in temperature. No. The second one says it is sensitive. Yeah, this is correct. Okay, C says it is very fragile. D says it is not very accurate. Okay, one of the features of advantage of the thermoelectric thermometer is that one, it is sensitive, and second, it can measure very high temperature. Okay, very high temperatures. Okay, this is just a revision of up to like 1100 degrees Celsius. Okay, in case you don't see sensitive, you can see very high temperatures. All right, so our right option here is option B. Question 31 of our UTME 2017 physics question, your Jamb CBT. It says determine the focal length of a thin converging lens if the power is 5 diopmeters. Okay, so we have P is equal to what? 1 over F. Okay, this is the formula for power of a what? Of a lens. All right, the power of a lens is what? P is equal to 1 over the focal length. So here we're told to look for the focal length. So F is equal to what? 1 over P. And what would that give us? That would give us 1 over 5. And 1 over 5 is what? 0.2 meters. Okay, now right option here is option B. Okay, to give you a quick revision, all right, of your lenses. All right, so your converging lens is a convex lens. Okay, is that the same as your convex lens? And you know, convex lens, they appear real or what? Virtual. Okay, it's either real or virtual. Okay, real or virtual, and it depends on the position of the object. Now your diverging lens is the same as your what? Concave lens. And a concave lens, the image formed is always what? Virtual. Okay, virtual, erect, and it doesn't depend on the position of the object. It's virtual, erect, and it diminishes, okay, and doesn't depend on the position of the object. So this is just a quick revision on this. And for the power of a converging lens is what's positive, while that of a diverging lens is what's negative. Okay, don't forget that. So when you see negative as the power of a diverging, when you see negative as the power of a lens, you should know that that lens is divergent, okay, and is a concave lens. All right, okay, so for this question, our right option is option B. Question 32 says, of your UTME 2017 physics question, Jamb CBT, it says, which of the following statements about magnetism is true? Okay, your first question, the first answer says iron fillings will concentrate mainly around the ends of a band magnet. B says lodestone is a non-magnetic material. C says like poles attract. D says a freely suspended bar magnet comes to rest in a geographic north and south direction. Our right answer here is option D. Okay, this is true about magnetism. So option D. Question 33 of our UTME 2017 physics question, Jamb CBT says, calculate the force on a 5-meter long stiff wire carrying a current of 8 amp and lying in a direction of 30 degrees to a magnetic field of magnetic flux density 0.6 for Tesla. Okay, so remember our formula here for the force that is acted upon a wire is what? F is equal to what? B-I-L sine theta, where B is what? Our what? Flux, magnetic what? Flux density. Okay, flux density, and I is what? Current, and length is equal to L is equal to what? That's the length of the wire. Okay, length of wire. And theta is what? The angle at which the wire is placed on the magnet, the angle to which the wire is placed on the magnetic field. Okay, that's lying in the direction of 30 degrees to the magnetic field. That's the theta angle. All right, so from here, let's put in our values. Since we are looking for force F, we are told that B, magnetic flux density, is 0.6. So we have 0.6 times our current is what? 8 times our length is what? 5 meter, and 30 degrees, our theta is 30 degrees, so times what? Sine 30. Remember, sine 30 is half, so we have 0.6 times 8 times 5 times 1 over 2. Okay, this will cancel out. This will be 4. So we have 4 times 5, that's 20. So we have 0.6 times 20. And what will 0.6 times 20 give us? To give us 12 Newton. So our right option here is option C. Question 34 of our UTME 2017 physics question, your Jamb CBT says, which of the following is correct about an electric cell? Okay, the first one says a primary cell produces a large current for a long time. No. B says secondary cell has a very high internal resistance. No. C says primary cell has a very low internal resistance. No. And D says secondary cell has a very low internal resistance. So option D is what correct. A secondary cell has a very low internal resistance, while a primary cell has a very high internal resistance. Okay. So our right option is option D. That's your secondary cell has a very low internal resistance. Question 35 of our UTME 2017 physics question, your Jamb CBT says, from the diagram above, calculate the total current in the circuit. Okay, so we have to look for the total resistance. Okay, all right, so the total resistance here, remember V is equal to what? IR. That is Ohm's law. So let's look for R. Okay, we're looking for I here. So I is equal to what? V over R. So looking for R will be what? 1 over R is equal to what? 1 over, since these are in parallel, to be 1 over 18 plus 1 over 12 plus 1 over 6. Okay, so what will be our LCM here? 36. So 18 in 36 is what? 2 times 2 times 1 is 2, plus 12 in 36 3 times 1 is 3, plus 6 in 36 6 times 1 is 6. So when you add this up, 5, that's 2 plus 3, 5 plus 6, that will give us what? 11 over 36. So R will, since this is 1 over R, to get your R, we have to invert this. So we have 36 over 11. So bringing this R here, we have our V is 12. So we have 12 divided by what? 36 over 11. So we have what? Inverting this, changing this sign to multiplication, we have 12 times what? 11 over 36. Where 12 go here 1 and 12 in 36 is 3. So we have 11 over 3. And what is 11 over 3? It will give us what? 3.7 amp. So our right option here is option B. Question 36 of the UTME 2017 physics question, that's your Jamb CBT, says calculate the angle of minimum deviation of a 60-degree prism of a refractive index of what? 1.5. Now to get the refraction of light through a prism, you have your refractive index N is equal to sine 1 over 2 bracket dm, which is the what? Deviation. That's the angle of deviation, minimum angle of deviation, plus your A, okay, divided by sine 1 over 2A. Okay, so here this is your angle of, we're looking for the angle of minimum deviation, which is dm. Okay, this m is supposed to be in small letters at the bottom here, and A is your what? Your refracting angle of the prism, which is what? 60. Okay, and N is your what? This N is the refractive what? Index, which you are given as 1.5. all right, so let's put in our values here. We are looking for dm. Okay, so we have N, which is what? 1.5 times sine 1 over 2 bracket dm plus 60 over sine, that's 1 over 2 times 60. So when this cancel, 2 here 1, 2 here 30, and what's sine 30? That is what? 0.5. that is half. So we have 1.5 equal to what? Sine 1 over 2 bracket dm plus 60 over 0.5. When it is cross multiply, 1.5 times 0.5, you have what? 0.75 equal to sine 1 over 2 bracket dm plus 60. Okay, so here, since we are given the inverted sign of 0.75 as what? 49 degrees. So all we need to do is divide both sides by sign. Okay, divide both sides by sign. So you have here, let's draw a line. You have here what now? Sine minus 1 0.75 equal to what? Here we just have dm over 2. Let's just divide this quickly, over then plus 60 over 2. Okay, this is what half multiplying everything in this bracket here. So, and we're told that this is equal to what? 49 degrees. So we have 49 degrees equal to what? dm over 2 plus what? This 1 and 60 will be what? 30. So 30. So here 30 will go to this side. We have 49 minus 30 equal to dm over 2. And what is 49 minus 30? That will give us 19 equal to what? dm over 2. And dm will definitely be what? 2 times 19. So dm equals to what? 19 times 2, which is equal to what? 38. Okay, and this is, I know this is an angle, so this is what? 38 degrees. So our answer is what? 38. Our right option here is option A. Question 37 of our UTME 2017 physics question. Your Jamb CBT says, which of the following statements is not correct? Number 1, it says molecules of a liquid are stationary. This is very wrong. Okay, so this is not correct, but let's read on. Say Brownian motion is an evidence of particle nature of matter. Yes. Matter is made up of molecule. Yes. The molecules of matter are in constant motion. Yes. So the statement which is wrong is option A. So that's our answer. Question 38 of our UTME 2017 physics past question. Your Jamb CBT says, which of the following is not part of the electromagnetic spectrum? Okay, A says alpha particle. Yes, this is not part. Okay, but let's read on. Gamma ray, yes, this is part of the electromagnetic spectrum. Infrared ray, yes. Radio wave, yes. So the right option to pick here, which is not part of the electromagnetic spectrum, is what? Alpha particle. All right, so that's option A. Question 39 of our UTME 2017 physics question. Jamb CBT says the diagram above shows the application of diode in A. A says full wave rectification, no. B says reverse bias, no. C says half wave rectification, yes. Okay, so our answer is what? Half wave rectification. If it's for a full wave rectification, you're going to see 2 diodes. Okay, 2 diodes. You're going to see 2 diodes, but this is a half wave rectification. We just have 1 diode connected in this circuit. All right, so our right option is option C. Question 40 of our UTME 2017 physics question. Your Jamb CBT says, which of the following instruments helps to maintain the correct humidity and temperature of a building? A says a compressor, B says a fridge, C says an air blower, D says an air conditioner. Okay, so the right answer here is air conditioner. It can't be a compressor, a refrigerator, or air blower. The right answer is what? An air conditioner. It maintains the correct humidity and temperature of a building. So the correct option is D.